హలో హలో పెన్ ఏది ఇక్కడిది రైటింగ్ పెన్ ఏది ఇక్కడిది ఇది కాదు నేను తీసుకొచ్చుకున్న పెన్ ఇక్కడ నేను తెచ్చుకున్నాను కూడా పెన్ను చూడు రాయడానికి కోసం restart you know good afternoon friends, welcome to this Made Easy GTQ program. Myself I am Srinivas. I will be discussing the digital logic subject, few of the important questions, few of the expected questions in the coming fourth exam, that is computer science GATE exam on 4th. Let me start this first question. So this question, if you look here, a Boolean function is given. When this Boolean function is realized using minimum number of 2 input NAND gates, when this Boolean function is implemented by using minimum number of 2 input NAND gates, the number of NAND gates required are equal to x, and using the same function when it is implemented with the minimum number of 2 input NOR gates, the number of NOR gates required are y. The question is, what is the difference between x minus y? It is a question. So basically we are having here a question as, when this given Boolean function is implemented by using minimum number of universal logic gates, that is one is NAND gate, other is NOR gates. When this Boolean function is implemented by using minimum number of 2 input NAND gates, the number of NAND gates required are x, that is a statement is given the problem. And whenever we are using minimum number of 2 input NOR gates to realize the same Boolean function, the number of NOR gates required we mentioned as y. So the question is now, what is x minus y? So what is the answer you are expecting? Try to mention your answer in the chat box. Try to mention your answer, try to work out on each and every question what are the questions I am going to discuss. Try to possible extent, try to give your answers. So go for a cross check with the right answer when I am going to discuss the answer. If you try well, the minimum number of 2 input NAND gates, if you try well, the minimum number of 2 input NAND gates we need 5. The function we are having here on 4 variables a, b, c and d. It is a or c and with b or d complement. So this function possible for us to read as B complement D whole bar. Let assume, or let us substitute M as equal to this B complement D whole bar. Then this equation possible for us to write as, in the place of B complement D whole bar we are writing M, so that it is possible for us to write as AM or with CM. So basically we are trying to look to the equation in the SOP form. Whenever we are trying to realize the Boolean function by using minimum number of 2 input NAND gates, it is better to have the equation in the SOP form. So once we are having it is a SOP form, with the knowledge of SOP expressions and with the 2-level circuits, possible to you to speak the answer for realizing this for realizing this SOP expression when we are using 2-level 9-NAND circuit. It is a circuit we will be having. It is a circuit we will be getting. We consider it is a M, so that the circuit output is a function F. But of course, M, what we are looking here, it is intermediate term. It is basically B complement D whole bar. So it is to be implemented again by using 2 input NAND gate. So for realizing this M, if you look here, one input is D and other input we need is to be B bar. So other input we need B bar. To get B bar, we need one more 9. We need one more 9 as an inverter. So based on this, if at all we are counting the number of NAND gates, definitely we are looking to the number of NAND gates as 3 plus 2, 5. So that for realizing this Boolean function, whenever we are trying to use the minimum number of 2 input NAND gates, we need 5 2 input NAND gates. Similarly, if you try the minimum number of 2 input NOR gates, the function what we are having here, this function is POS expression. This function what we are looking here, it is a POS expression. When this POS expression we are trying to implement by using with the NOR gate circuit, you know well, this is a circuit we will be having for implementing this POS expression. A POS expression implement करने के लिए, it is a circuit which is possible. It is a circuit which is possible. So here we need D complement. So D complement we are able to read if at all we are having the usage of the NOR gate as inverter. अगर आप a NOR gate को inverter कैसे use किए तो will be having D bar. So that we are having here effectively this function F. So basically the readout we are having as this function. If at all you had a practice the 2-level circuit, definitely without any verification possible to you to accept or possible to consider the output what we are having from here. It is this POS expression. So that we are looking here the minimum number of 2 input NOR gates. The minimum number of 2 input NOR gates we are having as 4. 3 plus 1, 4. So here we are looking to the answer x minus y. So definitely the answer we are having as 1. So answer to this first question, which is related with the Boolean algebra and which is related with the implementing of the Boolean function by using universal logic gates. So the answer to this question is 1. Come to this question. The given Boolean function, it is on 4 variables A, B, C, D. These are the minterms. Is to be implemented using 2-level AND/OR circuit. A Boolean function जो है, that is to be implemented by using 2-level AND/OR circuit. Here, the second part of the statement अगर आप read किए तो, which one of the following expression is to be used so that the circuit is to be static 1 hazard free circuit. So circuit must be static 1 hazard free circuit. and the circuit is to be implemented with the two-level AND/OR. So when we are implementing this function with the two-level AND/OR, the realization we want so that the circuit is supposed to be static one hazard free circuit. So to answer this question, you need to know the knowledge of the static one hazard. So basically, you need to know the knowledge of hazards. The knowledge of the hazards, it is possible for you to speak, which is possible, which one of the Boolean expression is possible for realizing this function as a static one hazard free. Let us try to read the expression for this function. So to read the expression for this function, it required for us to use the K-map. Of course, the function is on 4 variables, so that we must use 4 variable K-maps. So this is a 4 variable K-map. If you are having proper knowledge with the K-map, it is possible to look, this is 4, it is 5, this is 7, this is 14, it is 15. These are the cells. If you are having good practice, so without writing cell numbers, you are able to write or you are able to fill the corresponding cells properly. So if at all you are having any doubt, for your clarity purpose, here I am giving in detail. So these are the cell numbers. The minterms we are having for the function as 4, 5, 7, 14 and 15. These are the minterms. This combination 4 possible for us to read with this subcube product. This subcube product, when we are reading, the product we are reading as A complement B C complement. We are looking here, A is 0, B is 1, so A complement B, C is 0, so C complement, D is changing, it won't present. And the minterm 14 possible for us to read the group of these two cell subcube, that is the group of 14 and 15. अगर 14, 15 सब सेल को ग्रुप किए तो उसका प्रोडक्ट, if at all we are looking, it is giving A, B, C, A, B, C. So that with the knowledge of essential prime implicants, if you are looking to this expression, so these two products what we are having here, they are the essential prime implicants. These two products what we are marked here, they are the two essential prime implicants, so that in every possible minimal expression these essential prime implicants must present. So we are looking here, the minterm 7 is not covered. Minterm 7 is not covered by these essential prime implicants. So to cover the minterm 7, we are having possibility to use, the group of this 5, 7 cell product. So the group of 5, 7 product we are having as A complement B and with C. Sorry, A complement B and with D. So that if at all we are having the expression as A complement B, C complement, or with ABC, or with A complement BD, if at all we are using this expression, of course, in that case, it is the option A. But the question here what we are having is, the circuit what we are developing, it's supposed to be static one hazard free circuit. If at all we are using this product, then the problem is, whenever A value is changing 0 to 1, whenever this A value, with the knowledge of the static hazards, possible to you think, whenever this A value is changing 0 to 1, when it is changing 0 to 1, we will be looking at a problem of static one hazard. So based on this, if at all we are using this expression for realizing the circuit, so whenever you want to realize the circuit, the two-level AND/OR, the expression must be SOP expression. So when this SOP expression we are having the usage for realizing this expression, with this expression, if you try this two-level circuit, it is not going to be hazard-free circuit. You will be having hazard, as I explained, with the knowledge of the hazards, you can think whenever A is changing 0 to 1 or whenever A is changing 1 to 0, vice versa, we will be having a problem of hazard. We will be having the problem of hazard. So that the option A is not correct. Now, the other possibility, if at all we are looking, instead of using this product, it is possible for us to use the product. It is possible for us to use the product, the group of this 7 and 15. The group of 7 and 15, if at all we are reading the product is coming to be BCD. The product is coming to be BCD. It happened to be the option B. Even if at all you are looking to this, the circuit is to be hazard free. The two-level circuit what we are implementing on this expression, it is to be hazard free. अगर आपको hazard free होना बोले तो, when we are using this, if C value is changing 0 to 1, if the C value is changing 0 to 1 or C value is changing 1 to 0, you will be having a problem of the static one hazard. So that based on this, the option B also not coming to be true. Option B also not coming to be true. If we want to make the circuit is to be hazard free, then a part of these essential prime implicants, it required for us to use this product and also this A complement BD product and also this A complement BD product. When this SOP expression is used for realizing the circuit will be definitely two-level INR circuit, and with this two-level INR circuit, because of this expression we are looking, the circuit will be hazard free. So based on this, the matching answer, if at all we are looking, the matching answer is coming to be option D, A complement B, C complement, or with ABC, or with A complement BD, or with BCD. So that the right answer on this question we are having as this option D. So answer to this question is option D. Okay, so try to check your answers in parallel to me. So the time I given may be possible to you to work, because by this time you already prepared well, so you can try. If you are getting right answer, well and good. If at all you are unable to get the right answer, don't bother, don't get demotivated. We are having at least 10 days time, I think probably 13 days time you are having. So agar kuch gaps rahe to you can cope up to eliminate those mistakes while referring to our short notes or while referring to the class notes as a medium students. So don't get demotivated. You can make it well, not difficult. All such things are we already discussed in the class in detail. Come to the next question. This question is on this counter circuit. Initially all the flip-flops are cleared in the given counter circuit. The counter is having the mod value option A 6, option B 5, and is having unused states. In option C mentioned these 0, 1, 1, 1, 0, 0, 1, 1, 1. Option D may, these are the two states which are mentioned as unused states. So the question we are looking here, it is a MSQ question. Just try for your answer. Try karo answer ke liye. If you try well, the answer you'll be having on this question as option B and option C. These are the answers. These are the answers to this question. So to work out on this question, we need to analyze this counter circuit. We are having here the usage of three flip-flops. Flip-flop 0, flip-flop 1 and flip-flop 2. And the circuit what we are having here, it is not a synchronous counter. Try to identify well. अगर बराबर आप देखिए तो a circuit जो है, it is not a synchronous counter. एक synchronous counter नहीं है. It is not a synchronous counter because external clock is not coming to the flip-flop 2. It may be coming, of course, flip-flop 0 and flip-flop 1. अगर flip-flop 2 को देखे तो external clock is not coming to flip-flop 2, so that it is not a synchronous counter. It is a asynchronous counter. It is a asynchronous counter, but at the same time, as a medium students, you know, it is not a ripple counter. So we already discussed in the class. Every asynchronous counter may not be a ripple counter, but every ripple counter is an asynchronous counter. It is a asynchronous counter, it is not a ripple counter. You can see here what is the clock we are having, external clock. Based on this clock, for flip-flop 0 and flip-flop 1, we are having the possibility they may be changing based on, of course, inputs respectively. But flip-flop 2 is concerned, the flip-flop 2 is concerned, this is flip-flop 2. Flip-flop 2 is concerned, it is having possibility to change its value. It is having possibility to change its value whenever this Q1 value is changing. Whenever this Q1 value is changing 1 to 0. You know why it is so? They are having flip-flops with the negative triggered clock. So that whenever Q1 is changing 1 to 0, it is giving effectively the clock. It is giving clock effect to the flip-flop 2. So correspondingly, the flip-flop 2 will be toggling because J and K inputs are connected to 1, 1. So it is a toggle flip-flop. As and when effective clock is available to this flip-flop 2, the flip-flop 2 is going to toggle. So for every clock pulse, this flip-flop 2 is not having chance to change its value. It is having chance to change its value if and only the flip-flop 1 value is changing 1 to 0. But coming to flip-flop 0 and flip-flop 1, they are having possibility based on the respective inputs. For every clock pulse, they may be changing their values. This is the thing what you need to understand. It is a very good question. So we need to analyze this question. We need to analyze this counter circuit. Q2, Q1, Q0. If you look to the flip-flop 0 inputs, we are having J0 is equal to Q2 complement, and K0 externally K0 is connected to 1. So these are the inputs to the flip-flop 0. And flip-flop 1 inputs, if you look, we are having flip-flop 1 inputs, J1 is Q0 and K1 is connected to 1. These are the flip-flop 1 inputs. And come to the flip-flop 2. So flip-flop 2 is concerned, J2 and K2 both are connected to 1 externally. So effectively the T flip-flop, toggle flip-flop is a flip-flop 2. So here important thing is the flip-flop 2 is having chance to change its value if and only this Q1 is changing its value from 1 to 0. Agar Q1 is changing its value 1 to 0, then only the flip-flop 2 is having chance to toggle. It is mentioned initially all the flip-flops in the counter are cleared. So when all the flip-flops in the counter we are having clear means we are having initially all the flip-flop outputs as 0. Now while applying the clock signal, we have to check after how many clock pulses the circuit is back to initial stage. So before applying any clock signal, if you look to the flip-flop respective inputs, so Q2 complement is 1, it is externally 1, Q0 is 0, Q0 is 0, it is externally 1, of course they are connected 1, 1. So as and when we are applying the clock, because of this 1, 1 input, Q0 is changing 0 to 1. And because of 0, 1, the flip-flop 1 value is same 0. So we are looking Q1 is changing 0 to 0. Then Q1 is changing 0 to 0. It is not coming as a clock, or it is not giving clock effect to the flip-flop 2. Agar flip-flop 2 के लिए clock effect नहीं रहे तो flip-flop 2 will be same as the previous state. So it is same 0. So it is the content of this counter circuit, this asynchronous counter circuit after first clock pulse. Now before second clock pulse inputs, if you look, Q2 complement, Q2 is 0, Q2 complement is 1, Q0 is 1, this flip-flop 2 inputs are 1, 1. Now we apply the clock signal. Of course, it is happened to be the second clock pulse. If you apply the clock signal, because of this 1, 1, the flip-flop 0 is toggling. It is changing 1 to 0. Because of this 1, 1, flip-flop 1 is toggling. It is changing 0 to 1. Flip-flop 1 is changing 0 to 1, but it is not giving clock effect to the flip-flop 2. If it is not giving clock effect to the flip-flop 2 change nahi hote. Flip-flop 2 will be same 0. It will be same 0. So that after second clock pulse, we are having the content of the counter is 0, 1, 0. Now, before next clock pulse inputs, we check Q2 complement. Q2 is 0, Q2 complement is 1, Q0 is 0. These are connected to externally, of course, 1, 1. Now, if you apply the next clock pulse, it will happen to be the third clock pulse. ये तो third clock pulse हो गया. So this 1, 1. This 1, 1 is giving toggle effect on the flip-flop 0. So flip-flop 0 is changing 0 to 1. Now, because of 0, 1, the flip-flop 1 is changing 1 to 0. Flip-flop 1 is changing 1 to 0. When the flip-flop 1 is changing 1 to 0, this is giving clock effect to the flip-flop 2. If you look properly, अगर आप बराबर देखिए तो this Q1 change of 1 to 0 is giving clock effect on the flip-flop 2. Hence, the flip-flop 2 is changing to 1. So this is the content of the counter after third clock pulse. The counter is not back to the initial state. We are supposed to go on apply the clock pulses until the circuit is back to initial state. So we are going further clock pulses. Q2 complement. Q2 is now 1. Q2 complement is 0. Q0 is 1. 1, 1 here. When we are applying fourth clock pulse, because 0, 1, the flip-flop 0 is changing 1 to 0. Because of 1, 1, the flip-flop 1 is changing to 1. This is changing now 0 to 1, so it is not giving clock effect to the flip-flop 2, so that the flip-flop 2 is not changing. It is the content of the counter after fourth clock pulse. Before next clock pulse inputs, we check Q2 complement is 0, Q0 is 0, here 1, 1. When we are applying fifth clock pulse, because 0, 1 inputs the flip-flop 0, it is same 0. This 0, 1 is giving the change on the flip-flop 1 as 0. So Q1 is changing 1 to 0. Whenever Q1 is changing 1 to 0, it is giving clock effect on the flip-flop 2. Hence, the flip-flop 2 output we are having as 0. As 0. So that the circuit is back to initial state after 5 clock pulses. Hence, we mentioned the mod value of the counter is 5. And if you look well, the counter is switching in the states of initially it is 0, 0, 0. With the first clock pulse, it is coming to the state of 0, 0, 1. The second clock pulse, it is coming to the state of 0, 1, 0. The third clock pulse, it is coming to the state of 1, 0, 1, 1, 0, 1. The fourth clock pulse, it is coming to the state of 1, 1, 0. With the fifth clock pulse, it is back to 0. So that it is switching what we are having in the counter circuit. The states, if you are looking here, this 1, 1, 0 state is not, sorry. This 0, 1, 1 state is not present in the circuit switching sequence. So it is unused state. It is unused state. And this 1, 0, 0 also not used in the circuit switching sequence. AB nahi dikh raha. So it is also one unused state. And also we are looking this 1, 1, 1. AB nahi hai a switching sequence mein. So that these are the three states which are unused states. 0, 1, 1, 1, 0, 0, 1, 1, 1. These are the three states which are unused states. So based on this, the option C is also correct. For this MSQ question, the answers we are having as this option B and option C. So answers we are having for this asynchronous counter based on the question description is B and C. How many of you are able to answer? Raise your hands. Raise your hands. Mr. Hemant Krishna, you are mentioning combination of synchronous and asynchronous counter. Of course, you should not name combination of synchronous and asynchronous. On the whole, it is to be named as only asynchronous counter. It is to be named on the whole as only asynchronous counter. Good, good, good. So this type of questions were not the questions earlier in the GATE paper. Such type of questions are possible in the paper. Come to the next question. The next question also related with the counter, but of course here we are having a question: what is the maximum clock frequency possible to apply to this counter circuit? If you look here, the clock what we are having here, it is common to all the flip-flops. It is common to flip-flop 0, flip-flop 1 and flip-flop 2. So it is no doubt it is synchronous counter. It is not a synchronous counter, it is a synchronous counter. Look to the question description. In the given counter circuit, the propagation delay of flip-flop 0. So based on the notation Q0, Q0 complement is the flip-flop 0. The flip-flop 0, this is a flip-flop 1, this is a flip-flop 2. These flip-flops are having the propagation delays as mentioned 5 microseconds, 4 microseconds and 3 microseconds. So these are the values which are given in the statement of this question. And each 2 input NAND gate is having a propagation delay of 3 microseconds. The question what we are looking as a numerical question, the maximum clock frequency possible to apply to the counter in kilohertz. It is also very good question. So try to give your answers. Try to give your answers. Try to give your answers. So try to respond with your answers. If you are giving right, well and good. If not also, don't bother. Here, the questions what I covered, few of the questions we are going to look little simple. Few of the questions what we are having, little moderate. And few of the questions are little typical, you may not come across earlier. Without doing any mistake, you must give the answers correct for easy and moderate questions. Easy and moderate questions के ऊपर बिल्कुल गलत नहीं होना answers. And थोड़ा typical questions है, little difficult questions है. When you are answering to such questions, difficult questions, your rank will be definitely best rank. Your rank will be the best rank. Okay. So the answer, if you try well to this question, the answer to this question supposed to be 100 kilohertz. The answer to this question supposed to be 100 kilohertz. So let us discuss how it is so. So the counter circuit is a synchronous counter. It is a synchronous counter. As and when clock is applied, based on the inputs at the respective flip-flops, the changes will be having in the counter circuit. The changes will be reading in the counter circuit. Suppose, consider, as a medical students, couple of times in the class we already discussed this sort of thing. So if we say it is an nth clock pulse, when we are applying this nth clock pulse, based on the flip-flop inputs, you will be having the changes, and of course we are having a negative edge trigger. When the clock is falling, you will be looking at the changes. And before going to apply the next clock pulse, that is n plus 1, if you name it as nth clock pulse, it is n plus 1 clock pulse. What are the changes we are having in the respective flip-flop inputs? Those changes must available as the inputs to flip-flop 0, flip-flop 1 and flip-flop 2. So, जो changes मिलेगा nth clock pulse से, वो changes supposed to be available as the inputs before applying the next clock pulse. So, before applying the next clock pulse, कितना time ज़रूरत है? If you identify this time, if you identify this time, from this we are going to talk what is the maximum clock frequency possible. So a clock apply करने के बाद, because of changes, how much time we are in need to apply the next clock pulse, पता चलाना. So पता चलाना बोले तो at what time the flip-flop 0 input is ready after clock signal, after what time the flip-flop 1 input is available after applying the clock pulse. Similarly for the flip-flop 2, ये clock pulse डालने के बाद flip-flop 2 input कब मिलेगा, flip-flop 1 input कब मिलेगा, flip-flop 0 input कब मिलेगा, ये पता चलाना अपन, right? So if you look here, the NAND gates are having the propagation delay as 3 microseconds. This NAND gate, they are having the propagation delay as 3 microseconds. So as and when the clock is applied, the flip-flop 0 is changing its value after 5 microseconds. After 5 microseconds. A change होने के बाद a flip-flop 1 का input आपको मिलेगा 5 plus 3. A NAND gate be taking the processing time. We are naming as a, we suppose name is a propagation delay. So that a change होने के बाद this is available here as an input. So that it is available to this NAND gate as an input 5 microsecond. Second input क्या है NAND gate के लिए from the flip-flop 1. So flip-flop 1 is changing its value after 4 microseconds. So a दोनों में which is highest value? Definitely 5 is highest value. So that effectively the flip-flop 1 input is available after 8 microseconds. Flip-flop 1 input is available after 8 microseconds. And coming to the flip-flop 2 input. So flip-flop 2 input is coming directly from the flip-flop 1 output, so that flip-flop 2 input is available after this nth clock pulse just after 4 microseconds. Just after 4 microseconds. Now similar work we need to extend at what time the flip-flop 0 input is available. So flip-flop 0 input is available from this NAND gate output. So we are looking here in this path, there are 2 NAND gates which are involved. Okay, so for this NAND gate, one of the input is available after 4 microseconds, other input is available after 3 microseconds after this nth clock pulse. Among these two, higher is 4, so that for this NAND gate, the input is available 4 plus 3 after 7 microsecond. After 7 microsecond, one of the input is available. Second input is available just after 5 microseconds. Among these two, which is higher? Among these two, definitely higher is this 7. So that effectively this flip-flop 0 input is available 7 plus 3 after 10 microseconds. After 10 microseconds, it is available. So now if you are looking here, flip-flop 0 input is available after 10 microseconds, flip-flop 1 input is available after 8 microseconds, flip-flop 2 input is available after 4 microseconds after this nth clock pulse. So after changing, after getting all the inputs for at the respective flip-flops, we need to apply to the next clock pulse. Every flip-flop का inputs available होने के बाद, ये clock डालने के बाद, as and when the inputs are available, then only the next clock pulse is possible to apply. So based on this, we are looking here, the delay is more delay we are having for the flip-flop 0. So that if at all the minimum time we are having here as 10 microsecond, then only the circuit is going to operate properly. So this is the minimum time required between nth and n plus 1 clock pulse. So based on this, the maximum clock frequency, this is the minimum time required. So minimum time required to see the inputs to the respective flip-flops. So it is 1 upon 10 microseconds. So once in the case, we are having the answer as 100 kilohertz. So answer to this question is 100. We check how many of you given right. सब लोग check कर लो how many of you given right. I am looking. Many of you given wrong. Many of you given wrong. Again, this type of question was not the question in the earlier GATE paper. So repetition of the questions very rarely will be having the GATE paper. If you are tackling such questions in the GATE paper, if at all such questions are coming, and if at all you are able to answer correct to this type of questions, definitely your rank will be good. Okay? So what are the questions I am discussing? You might be observing, they are not very simple questions. While discussing this, looking many different concepts. Come to the next question. Next question, little simple comparing with the previous two questions. So here the question is, the Boolean function realized by the given digital circuit is. So this is a digital circuit. This digital circuit is basically built by using a 2:4 line decoder and 4:1 multiplexer. What is the Boolean function? That is f of ABCD. Boolean function realized by the given digital circuit. So from the given ABCD options, we need to identify which is the right answer. So try. You can make it. So to work out on this question, you need to know the knowledge of the decoder circuit. You need to know the knowledge of the multiplexer circuit. A decoder and multiplexer दोनों circuits का अगर आपको knowledge मालूम रहे तो then only you'll be able to answer to this question. Such questions are important questions in the GATE paper, if at all such questions are coming. Of course, it is also a MSQ question. If you try well, the answer to this question we are looking as this option B and option D. If you try well, अगर आप बराबर try किए तो you will be having answers to this question as option B and option D. Right. So if you look here, for this decoder, line 1 input is C, line 0 input is A. Okay, so line 1 is the MSB input as far as the decoder is concerned. Line 0 is the LSB input as far as the decoder is concerned. These are very important. Instead of here A and C, if at all it is C, it is A, it is something else, then the answer what we are going to look as is with this will mismatch. So which variables are connected to which inputs, very important to know. So if you look here, line 0 output, if at all we are looking, C complement, A complement. So C is MSB input, decoder is concerned, A is LSB input. Function is concerned, of course, A is MSB, both important as a concepts. So this C complement, A complement is the input to the multiplexer line 2. अगर line 2 input देखिए तो line 2 input, that is I2, we are having as the C complement, A complement. So similarly you have to work out for this I0, I1 and this I3. For this multiplexer, we need to identify what we are having as the inputs. So basically, based on the given circuit, the multiplexer inputs we are having from the decoder outputs, right? So if you look here, the decoder line 1 is connected as I0. So if you look here, this line 1 is C complement A. So that I0 is connected to C complement A. And if you are looking to this line 2, it is already verified C complement, A complement. So if you are looking to this line 2 is coming as the I3 input. The line 2, if at all we are looking from this decoder, it is C A complement. Be clear, it is C A complement. C A complement. Decoder का एक बार revise करो अगर if at all we are having any difficulty to catch. Very important, as MADs students, you know such type of questions we discussed, couple of questions. They are the concept level questions. So that we are talking now, line 3 input is C A complement. C A complement. And line 1 input is coming from this line 3 decoder output. It is C A. It is C A. So basically, for this multiplexer, we are able to look. You have to make a cross check well. If any mistake is there, then our answer is going to be wrong for reading function. So I0 is connected to C complement A. I1 is connected to CA. I2 of this multiplexer is connected to C complement A complement. Line 3, I3 input of the multiplexer is connected to CA complement. So after knowing this, with the knowledge of the 4:1 multiplexer output equation, with the knowledge of the 4:1 multiplexer output equation, it is possible for us to work out. The 4:1 multiplexer output equation is S1 complement S0 complement input line I0, S1 complement S0 input line I1, S1 S0 complement I2, S1 S0 input line I3. So it is a multiplexer output equation for the 4:1. Now if you look here, based on the connections, again one other important thing, S1 is connected to D and S0 is connected to B. S0 is connected to B. This is also again important as far as the multiplexer connections are concerned. S1 is connected to D, S0 is connected to B. Just randomly zigzag should not work, right? So once you know this, now knowing this, knowing the inputs of the multiplexer, we are able to read the function f of A, B, C, D. So D complement, B complement, S1 is D, S0 is B. So that D complement is B complement, I0 is C complement A. Next D complement B, I1 is CA. Next D B complement I2 is C complement A complement. The last term CA I3 CA complement. So based on the connections what we are looking to the multiplexer, it is the equation which is possible. Now from this we are able to recognize which are coming to be the correct answers. So if you reorganize properly the order of this A, B, C, D, we are looking here A, B complement, C complement, D complement, A, B complement, C complement, D complement. Next A, B, C, D complement, A, B, C, D complement. Next A complement, B complement, C complement, D. Somewhere this, sorry, here I did a mistake it seems. DB, this is DB, sorry. 8 and 14. So based on this, option B is the correct answer. It's a MSQ question, option B is the right answer, right? And to recognize among this ABD which is the right, we have to regroup these things well. So we are regrouping these things well. I think there is a printing mistake here, it seems. There is a printing mistake, it seems here. It must be C. It must be C, printing mistake. So you can see here, it is possible to group this term with this. When we are grouping these two terms, we are able to look here. Oh no. Oh, sorry. No, sorry. Group these two. So B complement, C complement will be common. So B complement, C complement will be common. Within the parentheses, we are looking here A, D complement, A, D complement. Next, A complement D. It is a term what we are having. And similarly, other two terms if you group, we are looking here BC as a common. These two terms if you group, BC is a common, and within the parenthesis we are looking as A, D complement or with A complement D. A complement D. So this is the expression what we are having. So from this we are looking here B complement, C complement. This is A exclusive RD. Here it is a BC. Here in the parenthesis A exclusive RD. So finally, if you're looking well, it is coming as A exclusive RD. A exclusive RD and with B X nor C. If you group well, it's a 1. So that answer to this question is, one of the other option is option D. So typing mistake either, it is to be C this. So anyway, answer we are having to this question as B and D. A question agar dekhe to answers are this. So what is the question we discuss here? This question demands the knowledge of the multiplexer. This question demands the knowledge of the decoder. So whenever you are working with the multiplexer or whenever you are working with the decoder, to look, just raise your hands. How many of you are able to answer? How many of you? How many of you were able to answer? So answering simple questions of course required anyway. But answering to such typical questions also very important to get the best rank. Okay, let us move to the next question. The probability of a self-real function, out of possible neutral functions using 3 Boolean variables, out of possible neutral functions using 3 Boolean variables is a question. So a question what we are looking is, by using 3 Boolean variables, out of possible neutral functions, how many functions are self-real functions? It's a question. The question is related to this. Of course, as a probability given as a question. As a medicine students, you know what is a neutral function, you know, and what is a real function, you know, and how many number of functions are possible by using n Boolean variables as a real functions, you know, and also you need to know the knowledge by using n Boolean variables maximum how many number of neutral functions are possible. This also we discussed in the class. The knowledge of this, you can answer to this question. Again, it is a good question. So from the MEDISI platform, you'll be having very good questions, not very routine, not previous year questions. But the questions we'll be discussing, you may not be finding in the previous GATE papers or from any other sources. I mean textbooks or any other source. Try for this. So somebody's answered. The answer, if you try well, It must be 0.23. It must be 0.23. It is the answer. The answer we want up to 2 decimal points. So 0.23 is the right answer. If you look here, let us look to the meaning of neutral function first. Neutral function means the number of minterms must be equal to the number of maxterms. We are naming a Boolean function as a neutral function as and when the number of minterms are equal to the number of maxterms. Then only that function we are naming as the neutral function. As a neutral function. So the question we are looking on 3 Boolean variables. By using 3 Boolean variables, all of you know well, total number of combinations are possible 8. So if a function is to be neutral function, अगर function neutral function होना बोले तो number of minterms must be equal to the number of maxterms we've said. It means half of the combinations must be the minterms. 4 combinations must be minterms. Out of 8 possible combinations, we want the 4 combinations are to be minterms. Then only the function we are having as a neutral function. Then only we'll be naming it as a neutral function. So 8C4, if you work out well, the answer will be having as to the power of n minus 1. So for this case, 3 variable case, effectively we are looking as to the power of 2 means to the power of 4, 16. So by using 3 Boolean variables, maximum number of real functions are possible 16, maximum number of neutral functions are possible 70. The answer we want as a probability, how many functions out of 70 are the real functions. So that's 16 by 70. So if you work out well up to 2 decimal points, the answer will be 0.23. It is not very difficult question. It is not very difficult questions. I am looking many of you given right. Very good. Many of you given right. I said already, every question may not be so difficult, what I am discussing. And every question may not be so easy. So it's a combination of easy and difficult and moderate questions. Come to the next question. The number of maxterms of the Boolean function f of a, b, c, d, e. So what we are looking is, function is on 5 variables. जो function है, 5 variables के ऊपर है. The expression what we are having here is B or C. A function का number of maxterms, it is a question we are having. A function का number of maxterms, it is a question what we are looking. Try for the answer. Try for the answer. It is a moderate question, not easy question, not tough question, but a moderate question. ये तो. I want to give the answer. If you are trying well, अगर आप बराबर try किए तो आपका answer मिलेगा 12. Number of maxterms of the function you will be having as 12. अगर बराबर आप try किए तो. The known answer you try, are you able to get? Yes, I am looking, few of you mentioned. Similar type of question we discussed in the class also. But probably that question was discussed for the minterms. So when we are having reached the function, without much knowledge of it all we are thinking, we are looking here, function is on 5 variables, the product is single variable. So that 4 variables are eliminated. 4 variables are eliminated means subcube size must be to the power of 4, 16. Okay, subcube size is 16. So that 16 minterms, with a group of 16 minterms, this product we are having. And similarly, if you think for this, we are having elimination of here 3 variables. Function is on 5 variables, the product is 2 variables. Elimination of 3 variables. So based on this, the subcube size, all this terminology you need to be familiar. As a medical students, definitely you know. So it is a group of 8 cells. It is a group of 8 cells. So that this is a group of 16 minterms, the group of 18 minterms. Now, if you are looking, you may be having 24 minterms. You may be having 24 minterms. But one important thing here is among these two subcubes of 16 cell and 8 cell, quite possible few the combinations or few the cells may be common in both these subcubes. एक है subcube 16 cell का, दूसरा subcube है 8 cells का. So that few of the cells may be common among these two subcubes. Based on this, the number of min-terms 24, what we are mentioning, mostly it is not the right. Mostly it is not the right. A question to max terms के लिए पूछा. Once you know the number of min-terms, you will be talking about the max terms. It is not difficult. So to answer to this question, multiple ways you can think. But easy way you need to follow. That is important. One of the way is by using 5 variable K-map. We discussed in the class as a medical students, you know. And other way, also as a medical students, you know, we can work out by using 3 variable K-map also. The product, the expression we are looking as B or CE, just we are looking here 3 variables. So that we are having a possibility to use 3 variable K-map. We are having possibility to use 3 variable K-map. It is B, it is CE, right? So in this 3 variable K-map, let us try to look for this SOP expression. How many combinations are the min-terms? So multiple ways we discuss the K-map work. So if you are looking well here, one of the way I discussed like this, it is a B, it is C, this is E. So the product what we are looking one is B. Once we are having a B, it's supposed to the group of these 4 cells, then only we are having it is a B. And other product is CE. Once we are having CE, it's a group of 2 cells. Right? It is giving CE. So that we are looking here 1, 2, 3, 4, 5. 5 combinations are the min-terms. Now this 3 variable K-map is to be used on this 5 variable K-map. When this 3 variable K-map is to be used on the 5 variable K-map, as you know well, using 5 variable K-map, total we are having 32 cells. Using this 3 variable K-map, we are able to accommodate only 8 cells. It is to be used on this 5 variable K-map means it required for us to use 4 such 3 variable K-maps. 4 3 variable K-maps अगर use किए तो you are able to accommodate 32 cells. Right? So if you are looking here, this we are looking with the 5 min-terms. अगर आप 4 maps use किए तो we'll be having 4 into 5. So we'll be having 20 min-terms. The function what we are having here, what is given here, is having 20 min-terms. So total we are having 32 combinations. Out of 32 combinations, 20 combinations are the min-terms. So that the number of max terms, if you are looking, the answer will be this 32 minus 20, so that 12. The answer is 12. It's the thing what I given. So it is the easiest way with the less time to answer this question. If at all such question is coming, it will be asked for 2 marks. So K-map means just learning small things learn करके छोड़े तो K-map work complete नहीं होते. As a medical students, you know well. So detail in depth, you need to learn the K-map. Okay, the answer to this question is this. I'm looking few of you given right. Very good. Let us move to the next question. It is related with the Boolean algebra work. If A or B complement R with A complement B is equal to C, then A exclusive or C is equal to, it is a question. Hopefully it is a simple question. Almost everybody, even non-medical student also may be able to answer to this question. So try fast. Very good. Many of you given right. Many of you given right. The right answer to this question is this. Very good. Many of you given right. As said, it is not difficult question. So we are looking here, this A or B complement R with A complement B. The statement, it is given as a C, right? Okay. Later, of course, in the question it is asked, what is A exclusive or C? It is a multiple choice question, MCQ. MCQ, right? So let us simplify. What simplified expression will be reading as LHS? We are looking here A complement, B complement, R with A complement B. I'm right? It is equal to C. It is equal to C. So that C we are looking as just A complement, because A complement is a common. Within the parenthesis, using Boolean algebra properties, you know it is 1, so that it is A complement. It is A complement, right? And coming to this required thing, A exclusive or C, it is A complement C or with A C complement. So in the place of C, we are having possibility to substitute A complement. In the place of C, we are able to substitute A complement. And if you want C complement will be equal to A. So that A into C complement may A. So it is giving effectively 1, because A complement R with A, it is the ultimate thing. So this you know well, with the Boolean algebra properties, it is 1. So answer to this question is option D. Okay? Let us move to the next question. Again, it is a very good question. A question of answer try karo. A question ka answer try karo. Again, it is a very good question. I am sure as a question of you may not come across earlier from any other source. दूसरा सोर्स किधर से भी आपको ये क्वेश्चन नहीं देखा होगा. So if you look here, the question what we are looking is, it is a 5-bit down counter. We are having a counter, it is a 5-bit down counter, right? The present state of this counter, the present state of the counter is mentioned as this. So present state of the counter is given as 01100. After 20 clock pulses, 20 clock pulses देने के बाद, 20 clock pulses देने के बाद, what is the content of this down counter? ये है question आपके पास. 20 clock pulses देने के बाद, what is the content in the counter is the question. Express your views. You are able to, you come across this type of question earlier from any other source? ऐसा question दूसरा जगह आपको मिला क्या? It is not a up counter, it is a down counter. From MEDIC platform, you will be getting always the quality learning, quality teaching, quality learning you will be having, and quantitative learning you will be having. Without missing any topic, you will be learning each and everything well. And it is very much required to perform well in the GATE paper. So I'm looking, few of you given answers as correct. Very good. The answer is this. Okay. So how to think to the answer with less time? Is a down counter present state we are having as 0, 1, 1, 0, 0. So for this equivalent decimal value, if at all you are looking, the equivalent decimal value, of course you know well, is a 12. Okay. So we are having the present state as 0, 1, 1, 0, 0. When we are applying the clock, first clock pulse डालने के बाद it is a down counter. So 12 से किधर जाना? 11 को जाना. It must come to this. And second clock pulse डालने के बाद it is the present state. We are starting from here. Second clock pulse डालने के बाद 11 है. 11 से 10 को आना. And so on, it must work out like this. So if you think well properly, it is coming to all zeros after how many clock pulses? If you work out well, definitely 12 clock pulses डालने के बाद आपको पूरा zero मिलेगा. If you work out well, right? So when we are applying 13th clock pulse, when you are applying the 13th clock pulse, all the bits are set to 1 because it is a down counter. It is a down counter, very important. 13th डालने के बाद all the bits will be 1. Right? Our question is after 20th clock pulse. अभी तक तो गए तो 13 complete हो गया. बाकी बचा कितना? 13 के बाद 7 clock pulses. So that from this we need to subtract this 7. We need to subtract this 7 because 13 होने के बाद और बचा कितना clock pulses? 7. So we can think here now it will be 1, 1, 0, 0, 0. So answer to this question is this. So think, it's a tricky question. It is a tricky question. Not easy, not very difficult question, but it's a tricky question. So answer to this question based on this is option C. Routine question जो previous papers में मिला, that is not enough to get the best rank. To get the best rank, that is not enough. So come to the next question. The Boolean function, it is on 4 variables. We are looking to the options as is having, this Boolean function is having unique minimal form. This Boolean function is having this set as a prime implicant set, and this Boolean function option C में बताया is having cyclic prime implicant K map. Option D में it is having, this Boolean function is having essential prime implicants and so and so. It is a question MSQ. So we are having a possibility for the more than one option as true. So try करो. This question, of course, you have to work out with 4 variable K map. With 4 variable K map. The questions are framed in this GTQ in such a way that if you are able to work out on these questions, default many of the concepts, almost 80-90% concepts of the subject will be clear. So wherever you are unable to answer anything related to that topic, try to refer to your notes. So 4 variable K map we need to use. So multiple ways I taught this K-map work. As a medical students, you know, this I can put as A, this is as a B. Instead of going to binary format, it's the best thing. This is C, this is D, and it is the order of the variables, right? And if you have tried well, you'll be having the answers. You'll be having answers. This is true, it is true, it is true. It is coming to be wrong. So answer for this MSQ question you'll be having as A, B, and D. These are the answers if you tried well. So we are having the midterms as this 4, 5, 6, 7, 9, 10, 11, 13, 14, 15. So intentionally without writing cells I mentioned here. So expecting you may be having a practice of using this as a medicine students. So anyway, for clarity I'm putting here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? Here, if you look, this midterm 4 possible to cover by using this 4 cell subcube. So the product, if at all you are writing, the product will be A complement B. The product will be A complement B. And the midterm 9, this midterm 9 possible to cover by using this 4 cell subcube, the product will be having here is AD. The product will be reading as AD, right? And the midterm, this 10, this midterm 10 possible to cover by using this 4 cell subcube, by using this 4 cell subcube. It is giving AC, it is giving AC, right? So that with these 3 subcubes, we are having coverage of all the midterms. If at all we are interested to write the minimal form, the minimal form definitely we are writing as A complement B or with AD or with AC. Apart of this, you are not having any other minimal expression. इसके अलावा और दूसरा minimal expression तो नहीं मिलेगा. So minimal expression will be having only one this. Hence the function is having unique minimal form. The function is having unique minimal form. It's the right option A, what we mentioned. And he's mentioning about prime implicants and essential prime implicants. Let's look which are the prime implicants, which are the products, which are the essential prime implicants. इसके अलावा they are having here the subcube products. We are having possibility. We are having a possibility of this 4 cell subcube, a product लिए तो this product we are reading as BD is a 4 cell subcube. And also we are looking a part of this, we are having coverage of the 14 with this 4 cell subcube. इसके से भी cover कर सकते हैं. It is giving BC. It is giving BC. So on the whole, if at all you are looking, these are the only 5 largest size subcubes. These are the 5 largest size subcubes. So from this, we are able to recognize the prime implicant set. Prime implicant set, if at all you are looking, the prime implicant set we are having as A complement B, A complement B, comma AD, comma AC, comma BD, comma BC. Apart of this, are you having any other prime implicant? Definitely answer is no. So if you are looking here, A complement B, BD, this BC, AD, AC. So that option B also right. And coming to the essential prime implicants, this because of the coverage of 4, it is essential prime implicant. Because of the coverage of the 9, this subcube product is essential prime implicant, it is AD. Because of the coverage of the 10, this product also essential prime implicant. So all yellow color subcube products are the essential prime implicants. As you know, the medicine students, the definition for the prime implicants and definition of the essential prime implicants, and also you know how to identify quickly by using K-map how many number of prime implicants and how many number of essential prime implicants. The number of prime implicants are equal to the number of all possible largest size subgroups in the K-map. Number of prime implicants are equal to the number of all possible largest size subgroups in the K-map. So that these are the 5 largest size subgroups, so that these are the 5 products which are the prime implicant set. And number of essential prime implicants are equal to number of all possible largest size subgroups in which at least one cell without overlapping. At least one cell without overlapping. A subgroup में देखो 4 overlapping से नहीं है. Hence the subgroup product is EPI. Similarly 9, similarly for 10. So respectively these 2 products also products corresponding to this largest size subgroups which are essential prime implicants. So answer, if at all you are looking, option D also right. And coming to the cyclic prime implicant K-map, as you know, in the cyclic prime implicant K-map, every minterm supposed to be covered by exactly 2 prime implicants. It is not happening so. Every minterm exactly not covered by 2 prime implicants. You can see here it is not covered by 2. If you see here 9 not covered. So that to answer to this question, you need to know the knowledge of what the means of the cyclic prime implicant. It is there in your notes. And how to identify the prime implicants and how to identify essential prime implicants, how to write the minimal forms. So many concepts I covered with a single question here in this GTQ program. Hence, finally the answer to this question is ABD. The answer to this question is ABD. I am looking, many of you given right. Many of you given right. Good. Come to the next question. It is a little simple question. It is related with the number system. Try. Hopefully everybody will giving answer to this. Hopefully everybody is giving answer to this question. Try karo. The result of this 44 radix 8 minus 54 radix 6 is stored in a 8-bit register. Is stored in a 8-bit register. A number 55 with the radix of 6 is subtracted from this. जो result मिल रहा, it is stored in a 8-bit register. Of course, storing we are having in 2's complement form. The content of the register is a question. The content of the register is a question. So if you try well, the answer to this question is this. The answer to this question is this, if you try well. So many of you given right. Those who given this, it is a wrong answer. Few of you given this, it is a wrong answer. Look here, this 44 base of 8 minus 55 base of 6. As a decimal values, if at all you are looking, the decimal value of this 44 base of 8, the decimal value of this 6, if at all you are looking, this is 36. This is 35. Sorry, decimal value. I said no, wrongly. 35. So that it is 1. It is 1. So our result is positive. The result is positive, right? When the result is positive, when it is stored in a 8-bit register in the 2's complement form, it is normal to sign magnitude. So sign magnitude, sign 1's complement, sign 2's complement, and the positive numbers will be same. Hence, the answer to this question is this. I said this simple question. All these things we will discuss in the class. Okay? So answer to this question is option C. Right? Let us move to the next question. It is the question related with the floating point numbers. Of course, in the regular MEDISI classes, these floating point numbers I am not discussing. These floating point numbers are discussed by the CO faculty. But anyway, as a part of the digital logic, you are having the GATE syllabus. So I am covering while looking to that point. Okay. So this question is related with the floating point number system. The following number in hexadecimal notation represents a floating point number in IEEE 754 single precision format. So this number is in the hexadecimal format, right? This is basically referring to IEEE 754 single precision format. So IEEE 754 single precision format, you know, it is 32-bit representation, right? The decimal equivalent value of this number is the question. The decimal equivalent value of this number is the question. So hopefully you can do. Hopefully you can do. If you try well, the answer to this question will be 164.375. ये आंसर आपको मिलना चाहिए, right? So let me work out here. It is in the hexadecimal form. This 4, 3, 2, 4, 6, 0, 0, 0. This is in the hexadecimal form. So let me write in the binary format 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, right? This is 4, this is 3, this is 2, this is 4, this is 6, and later, if you look here, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So, you are looking here, this is referring to sign, right? And these bits are referring to the biased exponent. It is referring to the biased exponent. And remaining part of referring to the mantissa part. And decimal value, the decimal value of single precision IEEE 754 number is -1 to the power of sign into 1 point this mantissa part into 2 to the power of exponent, real exponent. It's a biased exponent, right? So sign we are having here 0. Sign is 0 here. Sign is 0. And exponent part, if at all you are looking, it is a biased exponent, right? So this is 1, 0, 0, 0, 0, 1, 1, 0. So this is the bias exponent. Decimal value, if at all you are looking, it is coming as 134, 134, right? And real exponent will be minus biased value. Biased value will be 127 for single precision number. So that real exponent will be 7. And the mantissa part, of course, we are looking here. This. So from this, if you substitute the values here, the decimal value, if you read, well, so -1 to the power of 0 is plus, so positive number, and 1 point, this 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Later, of course, all we are having zeros. Into 2 to the power of 7. So if you work out well, it is coming 1, 0, 1, 0, 0, 1, 0, 0, 0.011. So if you work out well, definitely it is giving 164.375. So it is the answer. It is the answer. Right? Many of you given right. Good. Many of you given right. It's good. Let us move to the next question. The difference of the largest and smallest decimal number that can be represented using 6-bit 2's complement notation. That can be represented using the 6-bit 2's complement notation. Okay, simple question. Try to answer. So if you try well, the answer to this question must be 163. ये answer आपको मिलना चाहिए. So we are having here the question which is on 2's complement using 6 bits. The largest number, it is possible to represent in 2's complement using 6-bit. You see, it will be to the power of, in general I'm talking by using n bits, this. So because 6-bit, it is coming to be any 6, so that to the power of 5 minus 1, it is 31, right? And the smallest number possible to represent, is minus of to the power of n minus 1. So that any 6 which is giving minus 32. The difference of the largest and smallest, the difference of the largest number and the smallest number, it is the question. So that 31 minus of minus 32, 31 minus of minus 32. So definitely your answer is 63. So answer, I think sorry, लिखने में गलत हो गया. 63, answer is 63. Right. So for n-bit case, if at all you are looking, for n-bit case, if you are looking to the answer for this, definitely you are going to speak as to the power of n minus 1. ये है आपका आंसर for n-bit के ऊपर in general. So any 6, so to the power of 6 minus 1, so definitely 63. Okay. So given by mistake हो गया एक, few of you mentioning that 63 writing में गलत हुआ था. Let us come to the next question. AB exclusive or BC exclusive or CA is equal to, it is a MSQ question. So try. A question try करो आप लोग. Try for this question. If you try well, the answer to this question will be this option. This is D, option D. C and D are the answers if you try well. How many of you are getting? How many of you are getting these option C and option D as the answers? చూడు. So I am not looking answer from anybody. Suppose you supposed to feel this question is simple question. मगर आंसर किससे भी नहीं मिल रहा अभी तक. Nobody mentioned what I mentioned is correct. अभी तक कोई भी नहीं दे रहा. So normally you will prefer to practice like this. You prefer to practice like this whenever you are having exclusive or you prefer to write with this expansion most of the times. Most of the times you prefer to work out like this. But this type of work not better. This type of work is not better on this question. This type of work is not better on this question. If you try with this sort of work, it will take more time. It will take more time. So it is not better. The best way to work on this question is with the help of the truth table. The best way to work on this is it is better to work with the truth table. Right? So the expression what is given here, which is on 3 Boolean variables. You know well, on these 3 Boolean variables, we are having 8 possible combinations. So how to write 8 possible combinations तो मालूम है. A0 बाद में 0 1 1 0 1 1. So A पूरा 0. बाद में A1 डाल के रिपीट करेंगे 0 0 A0 1 1 0 A1 1. Right? So basically better to read the equivalent decimal values. Whenever you are working with the K-map, whenever you are working with the truth table, always it is better practice. Later, let us try to look AB. बाद में we'll try to look BC. बाद में we'll try to look this CA. Let us try to look. So AB, if at all you are looking, it is AB 0, either be 0, and basically whenever A and B both are 1, then only it is 1. A and B both are 1 here. Here. All pura jaga it will be 0. So simple. Looking to be lengthy, but if you are thinking proper way, in the proper direction, if you think it's simple. AB product कब मिलेगा आपको 1 whenever A and B both are 1. Similarly, if you look to this BC, B and C, this product will be 1 whenever this B and C both are 1, either and either. बाकी जगह पूरा 0. बाकी जगह पूरा 0. Similarly, coming to this CA, whenever C and A are 1, then only we'll be having 1. C and A, here this combination and last combination. Baki jagah pura 0. So it is looking to be lengthy, but the best way to work on this question. बाद में taking XOR between AB, BC and CA. Right? So whenever odd number of variables are 1, the XOR result is 1. So based on this, you know, here 0, here 0, here 0, here 1, here 0, here 1, here 1, here 1. So that the minterms we are having as 3, 5, 6 and 7. These are the minterms. So maximums, if at all you are looking, the maximums leftover combinations, missing numbers, 0, 1, 2 and 4. So based on this, one of the options C must be correct. Here, one of the options C must be right. Right. Then, if you look to this option A and option D, definitely you are going to identify they are not possible answers. If you want to have A exclusive or B exclusive or C, this result, whenever odd number of variables are 1, it must be 1. But here odd number of variables are 1, we are not reading as 1. So option A option A sahi nahi hai. And coming to this A XNOR B XNOR C, so we are having XNOR operation on odd number of variables. XNOR result on odd number of variables same as XOR result in the class we discussed. So based on this, A XOR नहीं मिला बोले तो XNOR भी definitely नहीं मिलेगा. So बचा क्या है D. So D identify करने के लिए we need to use a K-map of 3 variables. We need to use a K-map of 3 variables. So by using 3 variable K-map, you have to work out. So A, B, C, A, B, C. So min terms, SOP expression, so that you have to refer to the min terms. So 3, 5, 6 and 7. So we are looking here the subcubes as like this. So this is giving your BC. This is giving your AC. This is giving your AB. So that minimal form, if at all you are looking, it is coming to be ABR with BCR. Let me write here. You are reading, it is coming as ABR with BCR with CA. So options given options में which is matching? Definitely option D is matching. Hence answer we are having on this question is C and this D. It is a MSQ question. Okay, so we are having it is answer. So with this question I want to stop, but before stopping you can see what sort of questions we discuss, quickly. Let me discuss. So if at all you are looking at the first question is talking about your knowledge, how we are realizing Boolean functions using minimum number of 2 input NAND gates, minimum number of 2 input NOR gates. So by using universal logic gates, when we are implementing the function, how many minimum you need NAND gates or NOR gates, this knowledge is required. And coming to this question, when we are coming to this question, it is talking about the static 1 hazard. When you are learning about static 1 hazard, default you will be learning static 0 hazard knowledge also. A part of this we are talking here about the 2-level circuits, right? So come to this question. This question is a asynchronous counter. It is not a ripple counter. So this knowledge, if you are medical students, you know all this knowledge, information is available. So when we are working to this question, you identified the flip-flop 2 is changing whenever the flip-flop 1 is changing 1 to 0. So with that knowledge you are able to identify. So unused states are not reachable states. You can name these unused states even as a not reachable states. So it is required the knowledge how to analyze the counter circuit, right? Come to the next question. It is talking about how to identify the maximum clock frequency. To identify the maximum clock frequency, you need to know between 2 succeeding clock pulses minimum time kitna zarurat hai. While identifying between 2 succeeding clock pulses how much minimum time you need, you can able to speak at the maximum clock frequency. Come to the next question. In the next question, you need the knowledge of the decoder and also you need the knowledge of the multiplexer. A part of this, not routine way, what you will be looking in the textbook, S1 directly MSB को, S0 directly MSB, ऐसा नहीं हो सकते. A function के हिसाब से D is LSB is connected to S1 and B somewhere in the middle it is connected to S0. So based on this you have to work out for the function. And similarly on the decoder also similar type of thing I am having. A is MSB in the function, but A is not connected to the MSB input, right? So in detail knowledge if you are having on the decoder and the multiplexer, then only you are able to work out on this question. It's a MSQ question. So once you are working to this question, default you are able to revise multiplexer knowledge and decoder knowledge. Coming to this is talking about the neutral functions. It is talking about self-dual functions, right? Coming to this, it is talking about the K-map knowledge, right? So coming to this, it is a simplification using Boolean algebra property, this work. And here this question is a down counter, a good question. And what is shortcut? We need to identify the next state after 20 clock pulses we discuss, right? And coming to this, it is a just conventional paperwork question. How many we are having, how many products are the prime implicants, how many products are essential prime implicants, and function is having how many minimal forms related to this. As a part of this, you need to know the knowledge even for the cyclic prime implicant K-map. Coming to this, it is related to the number system, not difficult question, It is related with the IEEE numbers, floating point numbers. And coming to this, it is again related with the number system, 2's complement, positive numbers when we are having. Most of the time students will do some mistakes while working on this. And coming to this, okay. Coming to this last question, it demands the knowledge of exclusive or operation, but don't go with the conventional way on this question. If you try like this, it will take more time. So better to work with the truth table. So these are the things what we discussed in this GTQ. Okay, so I tried my maximum extent within this 1 hour 45 minutes time. What are the best things are possible, and what are the things you are looking here? Most of the things are new things. Okay, so hopefully you learn, you revise few of the things what you learned in the regular classes. If anything, try to mention the chat box. I will check your chat box. You try to express your feeling on the questions coverage what we did in this GTQ. Anything, any doubts or any question also, you can ask the GTQ questions what we discuss. Okay, I'm not looking any doubt from anybody. Hopefully you might identify what we discussed, what are the best things you are having in this GTQ 1 hour 45 minutes time. Okay, so my suggestion is possible extent revise your notes little fast. Wherever you are having any doubt on any question, any new question if you are finding, try to refer to the notes related to the topic only. Don't go from top to bottom. And examination point of view, my suggestion is don't give any wrong answer for simple and moderate questions. Simple moderate के ऊपर कभी भी mistake नहीं करो, wrong answer नहीं दो ना. You are giving correct answers for simple and moderate question, definitely you will be having little reasonable good rank. If you want to score best, then you have to answer well few of the typical questions what you are finding in the question paper, few of the difficult questions what you are finding. The difficulty may be concept, the difficulty may be with the paperwork, time may be, time consuming. So if you manage these things well, definitely your rank will be good. So wish you good luck, all the best, be in touch for any sort of doubts. Thank you, bye bye. Bye bye.